if we remember, ratios really are just fractions. That's it. It is just a fraction. We are comparing two parts. Ratios are just fractions. We can write it with the word two. We can write it with a colon, but we can also just write it as a fraction. And just like fractions, whatever we do to the numerator, we do to the denominator. And yes, I have to say it just like that every time to spell it right. So whatever we do to the numerator, we have to do it to the denominator to keep it equivalent. So if you want to divide the numerator by 2, you also have to be able to divide the denominator by 2. You have to do the same thing to both of them. So if we are looking at 3/5, we're changing the numerator into 9. So how do we get from 3 to 9? 3, 6, 9. We're timesing by 3. So if I did that to the numerator, I also have to do that to the denominator. 3 times 5 is 15. 3/5 and 9/15 are really the exact same amount. This one just has smaller pieces. 3/5, 9/15, they are equivalent. Whatever we did to the numerator, we did to the denominator. So an equivalent ratio is, so you can hear that word equal, right? Equivalent ratio. So an equivalent ratio is a ratio that, ratios that make the same comparison. So we just saw that 3/5 and 9/15 were equivalent. They're making that same comparison. They have that equal sign between them. So a basic ratio is a ratio that is simplified. The only factor is 1. The only thing you can divide the numerator and the denominator by is 1. So 3/5, the only factor they have is 1. So a basic ratio is just the simplified ratio. It's basic. It's as simple as it can be. Basic and simple. Equivalent means this is the same as this. So we're going to use this problem here. And oh, sorry, you guys, on your copy, I forgot to put the 2. So add in a little 2 right there. There are 2 cups of flour. I forgot the 2. And you need 6 cups of sugar for this recipe. So we're dumping in 2 flour, 6 sugar every time. 2 flour, 6 sugar. So we're going to, right, we have flour and sugar. So 2 cups of flour, 6 cups of sugar. First, it wants us to double this. So we're going to times the numerator by 2, which is 4. And then we're going to do the same thing to the denominator. 6 times 2 is 12. So if I use 4 cups of flour, that means I'm using 12 cups of sugar. We just doubled each of them. These are equivalent ratios. They mean the same thing. It was following the same pattern. Now, if I want to simplify and find the basic ratio, so if I was only doing part of this recipe, we need a factor that 6 and 2 can both be divided by. 2 can go into 2, and 2 can also go into 6. So we need to divide them both by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. So when we simplify that ratio, 1 and 3 can't get any more basic. That's the only factor that they can be divided by is 1. So equivalent, you can multiply or divide because these are equivalent as well. But this is 1/3. That's the basic simplified ratio. So we're going to practice some making equivalent ratios here. So if I look at my table, I'm missing a few boxes. If I look here, this is what I know. This time I want 4 cups of flour and 2 cups of sugar. So now I have to think, how am I getting from here to here. I always like to start at the front. So how did I get from 4 to 2? Well, we divided by 2. So I need to do the same thing here. 6 divided by 2 is 3. Now, from here, this is what I want to use every time. This is my basic ratio. I cannot get simpler. This is the basic one. I want to use this 2/3 every single time. So I always want to come back to the basic ratio. So I'm looking here. How did I get from 3 to 12? 3, 6, 9, 12. I times by 4. So if I times by 4 here, then I also have to times by 4 here. 2 times 4 is 8. So now I'm coming back to the basics because I don't know how to get from 12 to 18. So you either have to multiply or divide. There's not a way to multiply by 12. That's nice, friendly in my head, to get from 3. So we're going to come back to the beginning. 3 can go into 18 6 times. 3 times 6 is 18. So now I do the same thing to the top. 2 times 6 is 12. So if I want 12 cups of flour, I'm doing 18 cups of sugar. And now we have this 20, so it's on the top. So I'm going to come back to the basic, come over here. 2 times 10 makes 20. So now I need to multiply. 3 times 10 is 30. So we're starting with what we know. Get it to the simple. Then use your basic ratio to do the same thing to the top and the bottom. So this is the same thing. It's just sideways. We can do it either way. This one's up and down. So we know we want 4 cups of flour to 6 cups of sugar. So how do I get from 4 to 2? Dividing by 2. So to get here, I also need to divide by 2. 6 divided by 2 is 3. So now we want to use this basic ratio. It cannot get smaller to fill in the rest. So how do I get from 3 to 9? 3, 6, 9. I times by 3. So to get here, I need to do 2 times 3 is 6. So right, I did the same thing on both sides. I even wrote what I did. I made those connections and said I times by 3. So I need to times by 3. So now we have this 10. So I'm asking, how do I get from 2 to 10? 2, 4, 6, 8, 10. That was times by 5. So 3 times 5 is 15. And we have one more. It wants to know, how did I get from 3 to 24? Is 8 times. So now I need to do 2 times 8 is 16. So all of these, because it started as 2/3, they have the same basic ratio. All of these are equivalent to each other. They all mean they're following that same pattern. 2 of these, 3 of these, 2 of these, 3 of these. These are all equivalent. 2/3 is the basic ratio because it can't simplify anymore. So we're just following that pattern. What you do to one, you do to the other. What you do to one, you do to the other. Okay, and we also can use these basic, ratios, no N. I always put an N in there. I don't know why. So we can always find these basic ratios to figure out which ones are equivalent. If they have the same basic ratio, that means they're the same. So we're going to take these people, Leslie, Brett, Allie, Scott, and Nicole, and this is how many miles that they ran, and this is how many hours it took them, or walked, or whatever they were doing. So they were walking. This is how many hours it took them. So we want to see who was walking at the same rate. So I can see, so we're trying to find really their greatest common factor to divide them by. So 3 goes into 12 4 times. 3 divided by 3 is 1. So they already did that one for us. So now we're looking here. Can 6 go into 9? Perfect. No. Can 5? No. Can 4? No. 3? Yes. Oh, we can divide these both by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. So we can see Leslie and Brett were not walking at the same pace. Okay, Allie did 1 and 2. 1 is already the smallest factor. This can't get any smaller. It's already simplified. The only thing we can divide them both by is 1. So far, none of these people are walking at the same pace. Hey, now we have Scott did 6 miles in 9 hours. He's walking a little slow. So we already saw these common factors was 3. 3 can go into 6 and 9. So 6 divided by 3 is 2. 9 divided by 3 is 3. So even though Brett and Scott had the same numbers, they were in opposite places. These ratios are not the same. They're opposites of each other. They are not equal. Okay, so let's see what Nicole has. So 2 can go into 8 and 2. So its greatest common factor is 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So who has the same? Oh, I can see that 4 to 1. So every time it's been 1 hour, they're walking 4 miles. They're doing the same. So we can see that Leslie and Nicole went equivalent miles per hour. So every time they went 1 hour, they were walking 4 miles. None of the other ones are the same. So we're just looking for that factor, the greatest common factor, to divide them by. We made a basic ratio so we can see which ones are equivalent. So go ahead and make sure your notes are all filled out.